Powered Parachute Handbook 11.1 Approaches and Landings. Good day, aviators and enthusiasts. Today, our focus turns to the intricacies of the normal approach and landing procedures for powered parachutes, with particular emphasis on the land class. It is crucial to note that any information specific to powered parachute category C-class aircraft is not covered here but can be found in the Seaplane, Skiplane, and Float, Ski-Equipped Helicopter Operations Handbook, FAA 8083-23. Let's embark on a journey through the phases of a normal approach and landing, unraveling the nuances that define a standard operating procedure under favorable conditions. A normal situation entails the availability of engine power, light wind conditions, or a final approach directly into the wind. Furthermore, the final approach path should be devoid of obstacles, and the landing surface should offer a firm, level expanse with ample length for a gradual deceleration to a stop. The selected landing point should ideally reside beyond the runway's approach threshold but within the initial one-third segment of the landing area. To facilitate a comprehensive understanding of the factors influencing judgment and procedures, let us dissect the last part of the approach pattern and the actual landing into 5 distinct phases: the base leg, the final approach, the roundout, the touchdown, and the after landing roll. Before we delve into the specifics, it's essential to acknowledge the manufacturer's recommendations outlined in the Pilot's Operating Handbook, PO, for the powered parachute in question. These recommendations encompass crucial aspects such as powered parachute configuration, center of gravity, and other particulars relevant to approaches and landings. Any disparities between the guidance provided here and the manufacturer's recommendations defer to the latter. Our journey commences with the base leg, a critical juncture where pilot judgment plays a pivotal role. Accurate assessment of altitude and distance, considering wind conditions, is paramount to ensure a gradual descent leading to the desired landing spot. A constant ground track on the base leg, coupled with drift correction to maintain alignment with the runway centerline extension, contributes to a seamless transition. As we progress to the final approach, meticulous attention is directed towards aligning the powered parachute with the runway or landing surface. Any wind drift should be promptly recognized, and adjustments in power may be warranted to maintain a consistent descent. Focus on the longitudinal axis aligned with the runway centerline, with slight steering adjustments to stay on course. The descent angle throughout the approach is a critical factor controlled by throttle adjustments. A delicate balance is struck between throttle input and descent rate, with the wind's influence factored into the equation. The objective is to achieve a descent angle that facilitates a touchdown in the desired zone of the runway. In this dynamic environment, where power settings are not fixed, adaptability is key. Adjustments in power are made judiciously to control the descent angle or attain specific altitudes along the approach path. The flexibility afforded by partial power approaches empowers pilots to navigate varying scenarios, correcting course by either reducing or increasing power as needed. As we transition into the crucial phases of the approach, roundout, and touchdown, the significance of vision takes center stage. A panoramic view and a keen judgment of height and movement are paramount. Maintain a natural, straight-ahead head position to provide an expansive field of vision. Resist fixating on a single point. Instead, let your gaze shift gradually from just above the powered parachute's nose wheel to the intended touchdown zone and back. Simultaneously, remain acutely aware of the distance on either side within your peripheral field of vision. Accurate estimation of distance hinges on proper focus. Speed can distort objects at close range, akin to the blurs seen from a swiftly moving automobile. The powered parachute pilot's vision naturally adjusts, subconsciously focusing on objects sufficiently far ahead to ensure clarity. Attempting to focus too close or directly down blurs references, leading to overcontrol and imprecise landings. Conversely, focusing too far ahead compromises proximity judgment, resulting in delayed reactions and a tendency to fly into the ground without a proper flare. As we delve into the roundout, envision a slow, seamless transition from the normal approach descent rate to a landing descent rate. Gradually level the flight path a few inches above the runway, ensuring a continuous process until the powered parachute gently touches down. Initiate the roundout within 10 to 20 feet above the ground, applying power gradually to decrease the rate of descent. The rate of rounding out is contingent on the powered parachute's height and descent rate, adjusting proportionally to facilitate a smooth descent. Visual cues play a pivotal role, primarily influenced by the angle at which central vision intersects the ground ahead and to the side. Aim for a shallow downward viewing angle of 10 degree to 15 degree toward the runway during the roundout initiation. This maintains a consistent viewing angle, enabling you to gauge the rate of altitude loss by observing the visual interception point's rearward movement. Maintaining the same viewing angle is key, as it causes the point of interception with the runway to move progressively rearward, a vital cue for assessing altitude loss. Conversely, forward movement indicates an increase in altitude, signaling a need to adjust power settings. Keep a vigilant eye on the front wheel, easily visible in most powered parachutes, serving as an indicator of the main wheel's proximity to the runway. In certain scenarios, a slight throttle adjustment may be necessary to prevent excessive sink rates and ensure a controlled landing. Keep a hand on the throttle throughout the approach and landing, ready to respond promptly to unforeseen hazardous situations. This multifaceted approach, combining visual cues, depth perception, and throttle management, culminates in a precise and controlled roundout, setting the stage for the subsequent phases of the landing.